Okay, 16F, applications of the normal distribution, straight into some examples because there's not really anything new here, it's just applications. The Happy Time Chocolate Company manufactures a 100-gram chocolate nougat bar. As with any manufacturing process, these chocolate bars do not all have precisely the same weight. And these bars are known to be normally distributed with a standard deviation of 3 grams. To reduce the number of complaints, the company has adjusted its machinery so that the mean is 103 grams. Okay, they're making the weight a little bit higher so that people don't complain when their bars are on the light side, right? So, using the empirical rule where possible, and a table of values or technology, which means our calculators, find the percentage of chocolate bars that, part 1, have a weight of less than the stated standard deviation, less than the stated weight of 100 grams. Okay, so if I were to take my 100 grams and put it in my Z-score formula, I have 100 as my value. I'm going to subtract off the mean, which is 103, and we're putting that over our standard deviation, which is, in the question, 3. What does that equal? -1, that's right. So we are trying to find the percentage of people, if I draw my little normal distribution here, because we're meant to be using the empirical rule where we can, that have a weight less than 100 grams, which we now know is a Z-score of -1. So there's my -1, and I want the percentage of people that are, or bars, sorry, that are down there. Okay. Using the 68, 95, 99.7, one standard deviation is 68. Okay, but that's from -1 to +1. So if I were, that would be from those two there, between those 2 points. If I halved the 68, that means that that part there would be 34%. So how can I find the shaded in part that I want? 50% of my probability is less than the 0 there, down the center of my line, just minus the 34%, that's right. So I'm going to write this down as the probability that my Z-score is less than or equal to -1 is equal to, and I'm going to do it as a percentage, so it would be 50% for half of my data, and I subtract off the 34% that we don't want, which means that that is 16% of bars that are less than 100 grams. Does that make sense? Okay, on to the next one. Now we want the percentage of chocolate bars that have a weight greater than 109. So let's do the same kind of working out. Let's start by figuring out what is that as a Z-score. Using my Z-score formula, I do 109 minus 103 over the standard deviation, which is 3, which means the Z-score is 2. So using a diagram to help visualize, 0 in the middle, we have 1 and 2, and we want anything greater than 2, because that's greater than my 109 grams. What is that going to be as a percentage? Well, that one's going to be 34%. We knew that from before. But maybe we should just do from 0 to 2 all in one hit. That might be easier. What is from -2 to 2 as a percentage? That's the 95. So what is half of 95? 47.5. So that part together is 47.5%. Okay, so all we have to do to find the probability of a z-score of greater than 2 is to do our 50% minus the 47.5 that we don't want, which means 2.5% of chocolate bars would be above 109 grams. Half, that's right. Yep. And last one, B, what would the mean weight need to be for there to be less than one chocolate bar in 1,000 that is under 100 grams? Okay, so this is slightly trickier because we are changing the mean to try to make it so that very, very, very few bars are underweight. Okay, so this 1 in 1,000 chocolate bars is 0.001 as a decimal that are going to be underweight. This is going backwards question because I don't know what that is as an X value. Okay, I'm saying what Z score of something, I need to fill in the blank there, is going to give me a 0.001 probability of that. Okay, so this is one we definitely can't use our calculators for. We would need to use the table. Look through your table and try to find a probability. It says greater than, which means that is the, what would the mean need to be less than? Oh, maybe I put that sign around the wrong way. I might need a less than sign there. So it would be the smaller than portion. The smaller than portion. No. What did you get?
Oh,
Right. Okay, the problem is, and the reason that's why I changed to a greater than, is that this is would be a negative Z score. All right, let me go back to my other diagram. That's the value. This value down here is very small little value that I'm trying to find. The value of bars that would have a probability of less than 100 grams. So unfortunately, we would want to get a negative Z score out of that, which we know we're not going to get. So instead, if I'm using my table, I'm going to use symmetry to say what Z score would be greater than, that's why I have a greater than or equal to here, to get that 0.01. So in here, right down here, this is the smaller portion, which means I'm looking at these numbers here, 0.0013 and 0.0006. 0.001 is between those two things. So my result is somewhere between 3.00 and 3.25 as a positive Z score. Okay, so back here, if I go back to separate one, let me go back to, Okay, so the results that we had were 3.00. That was a probability of 0.0013, and 3.25 was 0.0006, and we are after 0.001. So let's go from the 0.0006. We need that to be 0.0004 bigger to get to the one that I want. Okay, what do I put that over? I put that over. The difference between the 13 and the 6. I subtract those two numbers in there, which is 0. Is it 007? 000, how many zeros? 3 zeros, 7. Then I times that by something. What do I times it by? It's the difference. It normally is, but this is actually a big jump between those two. So it's how much those ones have gone up by, which is 0.25. And that will give us, hopefully, our z-score. So what did you get? Actually, sorry, that's not quite the z-score, is it? That's how much I have to change the z-score by. So my z-score was 3.25 that I was working from, because I was working from the 0.006. Am I going to add on or take off that number? Take off the 0.1429, which is 3.1071. And that seems reasonable for what my z-score should be, 3.1071. Okay, now that I have a z-score, the z-score formula, as we know, because we use it all the time, is that. So if I go backwards through that formula, I could find out what the mean, which is the mu, needs to be to make this work. So my z-score, let's sub in, is, now wait a second, I changed that to be greater than 3.1071, but on my graph, what is my actual value for my question? It was negative. So I need to change that to be negative 3.1071 is equal to, what is the mass of my chocolate bar, the x, going to be? 100, because that's what we're telling everybody it is. We want the average, which is what we're trying to find, and our standard deviation is 3. Rearrange to find the mu. So times the 3 over, and you get negative 9.3213, 100 minus mu. And then you'll do a swap. So you add the mu across to the other side, which means you'll do 100 plus the 9.3213, which means you would need 109.3. That's probably way too many decimal places. Maybe I should just go to 3219, or what, 3213, sorry, grams, but I've just rounded to 2 decimal places. Okay, so that would have to be the average weight of the bar if you wanted to make sure that less than 1 in 1,000 were under your advertised 100 grams.